Hello and welcome back to Physical Science Online Notes. Today we are covering Energy BP3 on nuclear energy. Being realistic today, I'm going to aim for 2 videos. We'll see if I accomplish that or not. Kind of a warning ahead of time. Make sure you look at the nuclear learning targets so you know what to focus on. I know I personally love the nuclear topic, but it's only one learning target. So if I imply some stuff or say some stuff that's above and beyond those learning targets, just know that it's really cool stuff that I kind of get a little bit maybe too into. So learning target sheet is your friend. I'll try to keep it to learning targets as much as I can. So first off, maybe you've heard of nuclear a little bit with the electromagnetic spectrum when we did the waves unit. Nuclear energy is this one way to the right-hand side called gamma rays. Gamma rays are one thing that nuclear reactions can put off. It also gives off some particles, and there's some byproducts and other stuff. But one of the things that you might have heard of before is called gamma rays, that highest energy of the electromagnetic spectrum, shortest frequency. That's one of the things nuclear gives off. So really quickly, fission and fusion are our two types of nuclear reactions. It's kind of different than chemical reactions. Chemical reactions have to deal with bonds between atoms, whereas nuclear are dealing with one atom becoming two or two atoms becoming one, kind of more creating or destroying or breaking apart atoms instead of bonds between atoms. The cool thing about it is that nuclear reactions produce a lot more energy, like tons more energy. If you think of coal being another main source of energy here for humans, it takes about 1 train cart's load worth of coal, about the size of a classroom full of coal, to produce the same amount of energy as a pencil eraser's worth of uranium. So just the eraser of your pencil. I know I have a pen. That's what I had in front of me when I remembered that example. Same amount of energy in 1 pencil eraser's worth of uranium as a whole train car full of coal. So that's why we sometimes like nuclear. A little bit about nuclear energy here. Just as a reminder, energy cannot be created or destroyed. So nuclear reactions are still just transferring energy around. Chemical bonds have energy. That's where chemical reactions get energy from. And mass can be converted into energy. And that's what nuclear reactions are more using, is actually converting mass into energy. Nuclear reactions just transfer that into thermal energy, into kinetic energy is one of the things that they throw off as a result of that reaction. So they throw off gamma rays, that's a type of energy. They throw off particles, they throw out, and all of that becomes forms of kinetic energy that we can then harvest to do what we want with it. One of the things we use that for, and this is a picture, hopefully you do an ed puzzle on this. We'll also cover this again probably in the electricity unit in more detail, but here's as simple as I could make it. Nuclear reactors take that thermal energy from converting mass into energy, and they use it to heat water and turn a generator. So in our image here, that cool, you got the reactor over there heating stuff up through pumps and so forth, and turning water into steam, the steam generator, from going from left to right. And then that steam goes through a generator, which uses magnetism, principles of magnetism, to convert the kinetic energy as it carries through into electrical energy. There's a conversion rate using magnetism to convert that. Overall, it's an incredibly efficient process. That's why this same process is used for coal, and basically every form of energy other than solar uses this same process in some way or another. Let's break down our 2 types of nuclear reactions, though. As I kind of watch the time off to the side, I think we're still good. We'll get through this slide yet, and then we'll move on to the video 2. So nuclear fusion. Fusion, if you haven't heard of it before, is when 2 things fuse into one. So 2 nuclei become 1 nuclei. Places at this, and this takes a lot of energy. So places that can happen is the stars in the sun or in hydrogen bombs. That's the end of this video. I'll continue in video 2, and we'll learn more about nuclear.